Hello everyone, welcome to Ajiro Tech. Ajiro Tech. In this video, I'm going to be teaching you Chapter 2, Hardware and Software. And this is Cambridge AS/A levels. This is for the A-level students who, by reason of demand, said, Mr. Ajiro, just do a video on Chapter 2. Don't just do a video, teach us. And that is what I'm doing. If you notice, this is different from Chapter 1, which is straight up from the textbook, but this is something I've been able to put down so that I can properly guide you on this topic, hardware and software. For the O-level, you did, that's for ICT 0417, you did types and component of the computer system. And in the types and component of the computer system, you did hardware and software. But for A levels, we'll be going a little bit deeper. We're not just scratching the surface anymore, but we're going a little bit deeper in it. Okay, so stay with me. Trust me, this is going to be very, very informative. It's going to be eye-opening. You'll be learning a lot, not just looking at the screen, but you will be learning a lot, guaranteed. Okay, and please don't forget to subscribe to my YouTube channel, Ajiro Tech. Trust me, it is an amazing YouTube channel. A lot is happening in there. Okay, so let's go ahead. Lesson objective. Yeah. So in this lesson, these are the things you're going to learn. We're going to talk about the characteristics and uses of the mainframe computers and supercomputers. And we'll also be looking at the types and uses of system software. We'll be looking at the need for, types and uses of utility software. We'll be looking at the use of custom written software and the off-the-shelf software. This is usually what Mr. Ajiro, I'm confused between custom written and off-the-shelf kind of software. We're going to look at it in this video. Okay, so stay glued. If you're watching from your laptop, if you streaming this from your smart TV or from your mobile phone, just stay with me on this. Okay. And finally, we'll be looking at the types and uses of user interface. Yeah. So let's get this started, okay? Yes, mainframe computers, okay? So the mainframe computers is often referred to as mainframes. Okay, so just in case you've been asked what are mainframes, you go, okay, mainframe computers, which is it really? It's also the same thing, okay? It's also the same thing, okay? So they are used mainly by large organizations. Okay, so you can see that right in the slides for bulk data processing applications. Okay, such as Census, industries, etc., etc. Okay, a mainframe is a multi-tasking, multi-user computers. How do I explain this? Now, before I come to multitasking, just pay attention to this. Most individuals, okay, tend to use personal computers, okay? And that's what we're all using right now. You're using your laptop, your desktop computers, your smartphone, your personal computers, okay? But mainframe are much larger, okay? And have more processing powers than this, okay? And also it is expensive, okay, to buy as well, okay? So please, we have to take note of that, okay? Now, also, the mainframe computers have continued to evolve and are still in use today. So we're not talking about something that is outdated. Okay. Now, mainly because of their features, such as the ROES. Okay. I told you today I will be teaching. So let me see if I have my such as I think I can put it up here. Such as what? Okay, such as the ROAS, which will go in more details later in the section. So take note of what I've talked about, the ROAS. Okay, so let's take note of that. It's very, very important. Okay. Most PCs and laptop used to have a single processor, okay, but today they tend to have a CPU with many cores, okay, which gives the effect of having many processor. Now, I hope that makes sense. Okay. Now, back then we have some PCs that have just single processor. Now we have them that have many cores. Okay, many core to it. You can just have a single processor, single core, but then we have dual core. We have octa core. We have quad core. Okay. Now this allows this computer to carry out what we call parallel processing. Okay. Parallel processing rather than just rather than what we call the serial processing of their predecessors. Okay, so here we can see that I'll come back to the parallel and serial processing. I'm going to come back to it. Okay, so pay attention to this now. But let's look at the fact that mainframe is multitasking, multi-user computers. Simply means that many people can use a computer. It can be used to carry out a lot of tasks. Okay, that's what it means. Okay. Okay, so I have an empty blank slide that I want to talk about this. So let's talk about it. The parallel processing. I told you today I'm going to teach you. Yeah. Okay. So let's talk about the parallel processing. So we'll talk about parallel processing. This simply means that they allows several tasks, okay, to be what carried out. Okay, simultaneously. Okay, simultaneously. But in the case of the serial processing, okay, for the serial processing, this is when the PC performs tasks one at a time. Okay, so this is very, very important about the parallel processing and the serial processing, because oftentimes that can actually come out. Okay, so when we talk about the parallel processing here, this is because we're talking about how most PCs and laptop tend to have a single processor, and now they have multiple cores. Okay, so for parallel processing, they allow several tasks to be carried out simultaneously. For serial processing, they perform one task at a time. That's why you see that most PCs, they are parallel processing. Okay, so this is very, very important. Okay, and that is why a mainframe computer can have hundreds okay, can have what? 100. Mainframe. Sorry, this should be serial. A mainframe computer can what? Have. Okay, can have what? Let me clean this. Okay. Can have hundreds of what? Processor cores and okay. And can okay, so okay, can process a large number of small tasks at the what? Same time. Very quickly. So this is mainframe computer. So it's important for us to note that yes, they have hundreds of processor cores and they can process large amounts, okay, of these small tasks at the same time very quickly. Okay, so this is very, very important. Okay. Now, yes, we do have the most more powerful ones, like your supercomputers, okay, which have in excess of 100,000 processing cores. Okay. Remember, if you watch my video chapter one, and please, if you've not watched my video when we talked about the chapter one, please you should. Okay, it's very important that you should look at it when we talk about data and information. So please, if you've not watched that video, please you need to watch it, and if possible put a pause of this, put a pause on this and go back, watch it, and then come back to this. It's very, very important because in the first video, which is the chapter one, we looked at batch processing of payrolls, how we can do that. Okay, now a supercomputer can multiply different hourly wages rates. From, we talked about the master file by list of hours, from the transaction files for hundreds of workers roughly the same time, and it will take a personal computer to calculate the wages of just one employee, etc., etc. Okay, so please, that is very, very important. Now let's talk about the example. Here we have the example. Right here we have the example of mainframe computers. Okay, the one I can think of right now is the one you're seeing right here, which is the IBM Z15. Okay, it has up to 190 cores. Okay, its predecessor, which is Z14, came with 170. Okay, and they're used for large banking organizations. Okay, even some government departments they make use of it. Large insurance organizations they make use of it, etc., etc. Okay. Okay, let's talk about supercomputers. A supercomputer is a computer that performs at or near the highest operational rates for computers. That's what they are. Okay. The supercomputer is a computer that performs at the highest operational rate for computers. Okay. And this is a picture of an example of a supercomputer. This right here is Cray XC40. Okay, supercomputer. Now it has, okay, up to, get this, 172,000 processor cores. Okay, several countries which have one of these, and they use them in fields of weather forecasting, scientific research, such as a lot of things mathematical or computational modeling. So this is very, very important. The next thing we want to talk about. Okay, so quick classwork. Which is the fastest between the mainframe and the supercomputer? You can pause and answer, and then I will answer. Okay, so the fastest obviously is a supercomputer. Okay, so if you said supercomputers, bravo. Okay, all right. So let's look at the next one. Characteristics of mainframe computers and supercomputers. The first one is longevity. Yes, longevity. Mainframe computers have mainframe computers have great longevity or lifespan. Now, this is because they can run continuously for very long periods of time, and they provide business with security in the shape of extensive encryption in all aspects of the operation. Okay, telecommunications, government institutes still base their business dealings on mainframe. Okay, many of these computers have existed for decades and are still working well. Okay, so because of the longevity and lifespan, okay, so it can run continuously for long period of time. Now, to shut down, then dispose of the hardware is very expensive. Okay, it's very expensive to do that, so it runs for a long period of time. Okay, it's very, very important. The next one is, now I promised you I was going to talk about the RAS, so let's talk about it quickly. I think what I can use here. Let me see. Okay, I can use here. So let's talk about the RAS. Okay, I think I have this. So let's talk about it. Now, when we talk about RAS, what does it mean? This simply means reliability, okay, availability, and finally, service ability. I bet you did not guess that one. Yes. And then one of you were hearing service and you get like, okay, it's service. And then I had to add ability. And you're like, okay, this is new. Yes, so we have reliability, availability, and serviceability. Okay, so when we talk about the RAS, okay, let me just put this quickly here. Let me just put this. Okay, so it's frequently used, okay, when we're referring to mainframe computers. Okay, so most time you can hear about RAS and you're like, okay, Mr. Ajiro, Okay, I need your help. What's RAS? Okay, so now you know what it is. So it means reliability, availability, and serviceability. Okay, that's what it is. Okay, and RAS is not just a term that is used on the whole with supercomputers. Okay, it simply means how reliable is the supercomputer, how available they are, and in terms of the service that they render, how well do they do that? And that's what we're here to talk about. Okay, so it's very important that you stick with me on this. Okay, I put it right here as part of the characteristics, so now you know where they're coming from. Okay, so right here we have reliability as part of the RAS. Okay, so it simply means that mainframes computers are the most reliable computers over other computers, other personal computers that you have. Okay, because their processors are able to, watch this, check themselves for errors. Okay, and to recover without any undue effect on the mainframe operations. Now, the system software, okay, is also very reliable as it is thoroughly tested, okay, and updates are made quickly, okay, to overcome any form of errors. Okay, so while the system is running, they're making updates to ensure that even if there's a slight of a bug, those errors are being overcome. Okay, the next one is availability. This refers to the fact that a mainframe computer is available at all times and also for extended periods. Okay, now I'm going to talk about this. Okay, so whenever I want to talk about something, I go back to the slide right here. Okay, so I'm going to talk about MTBF, which simply means mean, okay, time between failures. Okay, I know. Most people are like, okay, when you saw about the between, you're like, no, that's what it is. Okay, that is what it is. Can you see in the exam? That's what it means. It means mean time between failures. Now, what it simply means is a common measure of system, okay, not just those involving computers. Now, mean time between failures is an average period of time that exists between failures. What are those failures? Now, watch this. This is something that you probably must have heard, but you really did not know what it means. Downtime. Most time you hear that a system is having downtime, it simply means that they have run into failures. Yeah. Okay. So they use the downtime to soften. You know when you tend to use some words that are, you try to use some words that try to convey your expressions in a most simplified manner, and instead of just going straight to the point, that's what downtime is. So that's what it means. Okay, it's an average period of time that exists between a failure. They tell you that there's a downtime between this and this. That's what it means. Okay, so of a service operation doing its normal operation. Okay, so mainframe gives months or even years of system availability. Yes, they do. Okay, between system downtime. So before you have any downtime in mainframe, it's going to be a long time. Okay, so in addition to that, just to add to it, even if the mainframe becomes unavailable due to downtime, okay, now you're getting the gist. Okay, the length of time is unavailable is very short. You could have a downtime for like 10 minutes, and every operation is back to normal. Okay, so it is possible for a mainframe computer to recover quickly even one of its components fails. It's possible by automatically replacing the failed component with spare. So while the computer is running, you can be replacing the spare parts. Okay, spare CPUs are often included in mainframe, so that when errors are found with one, the mainframe is programmed to switch to others automatically. So if there's a failed CPU, it switches to the next one automatically without having to halt any form of operation. Although there might just be a slight downtime, but we're good to go. Okay, of course the operator would then be alerted, and the 46 CPU is going to be replaced, and all the system continues to work as if nothing happens. All right, finally on RAS, serviceability. When we talk about serviceability, this is the ability of a mainframe to discover why a failure occurred. Why did it occur? It's not just working on those errors, but there's a need for you to know why it occurs so that next time you don't have those errors again. And the means that the hardware and software components can be replaced without having to go too great, or without having to have a damper on the day's operation. I don't know if I'm communicating by here. Okay, so as you're taking your notes and stuff like that, so it simply means that when there's a downtime, okay, and obviously we've talked about availability. Okay, the 40 CPU is being switched to the other one and it's being replaced, and all operation is back to normal. You need to know why you had that downtime, why there was a failure, why it occurred. And what helps you is a log. You can be able to look at the log to say, okay, this occurred so time, probably in the night or whatever, and then you can be able to know the reason why that is, so that you can work on it to ensure that it doesn't go to that length again. Okay, let's go back to our characteristics. So this right here, so the characteristics says longevity and security. This is part of the RAS, okay, which we talked about. Like I said, they are frequently used when we're referring to the mainframe computers, and it is very important that we talk about it. All right, so for security, which is another characteristics, is in addition to other characteristics, this also falls as part of the characteristics as well. But when we talk about RAS, this is what we mean. Okay, mainframe have great securities than other types of computer systems. Okay. Data security is considered to be the protection of data. That's what it means. Okay, from intentional or accidental destruction, modification, or disclosure. Okay, I'm just going to explain this again. When we talk about data security, it simply means that you're protecting your data from any form of intentional or accidental destruction, modification, or disclosure of that data. Now, mainframe are used to handle large volumes of data. This is what we know. Most of this is personal data, okay, especially in the banking sector when you have to talk about money. And trust me, money is very, very important. It is. Okay, it is. You can't have money in your bank unless you have like $20,000, and you go to bed and come back in the morning and you're seeing $5,000. You get mad. You scream. Okay, you go to the bank. You demand the bank manager, and you don't talk in a friendly manner. You escalate. You flame up. You know, you're like, what is happening? Somebody talk to me. Where did my money go to? Okay, where did my money go to? I want to know. Okay, just messing with you. Okay, so yes. Okay, so it's to be shared with customers. Okay, so this means that data has to be extremely secure, not just the money, but their personal data, their social security numbers. Okay, it's very, very important. Okay, so it has to be very, very secure. Okay, and that is why a mainframe has many layers of security, and we're going to talk about that. So what are those layers of security that the mainframe computer possesses? At this point, if you're enjoying the class, please give a like to this video. Okay, give a like to this video. Just let me know you're liking the video, comment on the video. Just let me know if you're actually learning, because the feedbacks you guys give to me improves me, helps me to improve as a teacher, as your favorite YouTube teacher. Yeah. That's what I'm being called right now. Ajiro, you're my favorite YouTube teacher. So it helps me to improve and to give you guys nothing but the best. Okay. Okay, let's get back. Okay. So let's talk about those layers really. The first one right here on your screen is user identification and authentication. Yeah. Now, although more and more systems are using multi-factor authentications, okay, which is a combination of two or more of the following. We'll talk about sometimes you see two-factor authentication. Now we have multi. We'll talk about multi is more than one. Okay, two-factor is also part of multi-factor authentication. So we'll talk about combination of two or more. Okay, that's what we're talking about. This includes you have a password. That's good, but then there might be a need for a physical token. And not just that, it could be a password, it could be a physical token, it could also be a biometric identifier. Because you might guess someone's password, you might even possess their token, but biometric identifier simply means that the person has to be present. We'll talk about biometrics. This is something that is unique. Okay, part of your body could be. We have, what are those types? Quickly, it's not in the slide, but I'll just put it in. So if you're actually studying with this, maybe a personal study, a group study, you might want to write this down. You have fingerprint, retina scan. Okay, you have even signature. Okay, voice recognition. Okay, so it is very, very important. Okay, so this is one level of security that the mainframe computer tend to pose, which is very, very important. The next one is levels of access. Yes, not everybody gets to have access to every kind of data. If you tend to watch some of the movies that I watch, okay, let me say, yeah, you watch movies? Yes, I do. And what kind of movies? FBI, other crime movies. You see that most people have certain clearance levels. Some have just clearance level to like level 5. Some have level 6. Some have level 8. It simply means that the people that have level 5 cannot be able to access information on level 8. Yes. Cannot be able to access information on level 8. Okay, so it means that it depends on the user's level of security as to which set of data they can be able to access. Encryption of transmitted data and data within the system. So every data transmitted is secured, even data within the system, to ensure that we don't have people trying to breach in the system to get any form of information. Another thing about a mainframe computer is the fact that they have a secured operating system. They do. That's another layer of security. They have a secured operating system. Okay, and finally, they have continual monitoring by the system for unauthorized access attempt. Okay, so there's always 24/7 monitoring to ensure that the moment there is any unauthorized access attempt, there is that beep. It makes a beep. If you watch those movies again, like I watch those FBI, CIA movies, you see that once there's a breach, automatically the system locks everyone out. Okay, especially if it's a very serious breach, and everybody will have to go through the whole process again. Okay, so this is very, very important. Okay, the next one is performance metrics. I want to talk about performance metrics. Okay, now when we talk about performance metrics, okay, of a computer, they are basically the measures used to determine how well or how fast the processor deals with data. That's performance. We want to know the metrics. How fast, how well you're dealing with the data. Okay. Now the speed of a mainframe CPU is measured in, please write this down, millions of instructions per second. It's right here. Millions of instructions per second, right? MIPS. Okay. Okay. However, it is not always the best measure. Sajja, what do you mean? Not all instructions are the same. Do I have a yes? I promise you guys that this is not just going to be a slide presentation. This is going to be me teaching you. Okay. Mainframe use a very large numbers of different instructions. So it's not the same instruction. So while we're looking at the performance matrix that determines how well or how fast the processor deals with the data, okay, it's not always the same measure. Okay, because with there are some performance metrics that are just straightforward and they're easy to carry out. Others can be more complex and slow to process. Some will just be in an instant. Some is going to take time. That's what I mean. Okay. Now, an application using 5 million simple instructions will take a lot less time than using 5 million complex ones. Okay, when you're giving instructions to the computers to just do this, do this, do this, do this, that's what instruction means. You're giving instruction to the computer, you're giving an input, do this, it's going to do that. But when it's complex, it's going to take time. Okay, so the numbers of available instruction is increasing as time goes on and mainframe improves. Okay, I'm just going to end with this. It is important, please note that it's important that the comparison between the performance, okay, of one mainframe and another is made by what? Measuring how fast the CPU are when carrying out the same task. This is often referred to as benchmark test. Okay. Okay. The next one, before we look at fault tolerance, before we look at the fault tolerance, I want to talk about the volume of input, output, and throughput. Yeah. So I'm just going to write this here because I want to talk about it. So I have the volume of input, output, and what? Throughput. Yeah. Now, these are very important when considered describing computers. Okay, mainframe have specialized hardwares. Okay, and these specialized hardwares are called what? Peripherals. What? Okay, let me just put that. Mainframe have what? Specialized hardware. Okay, and they are called peripheral what? Processor. Okay, now these peripheral processors, right, they deal okay, let me see. Okay, probably they deal specifically with all input and all input and output operations. okay, leaving, please take note of this, leaving the CPU to what? Concentrate on the what? Processing of data. Now I'm going to stop here. I want to explain. We've talked about the fact that the mainframe have specialized hardware called the peripheral processors. Okay, and they deal specifically with all input and output operation, leaving the CPU to concentrate the processing of data. Okay, now this enables the mainframe to deal with very large amount of data being input. Now, this large amount of data could be, example could be terabytes or more. Okay, large amounts of data, okay, being input. It could be record being accessed, okay, and because it gives time for large amount of data being input, you also expect large amount of output being produced. Modern, and I need to write this down, so please take note of this. Modern mainframe can carry out many billions of what? Transaction every day. Okay, now these large numbers of simultaneous transactions and extremely large volumes of input and output in a given period of time is referred to as throughput. I come again. This large number of simultaneous transactions and extremely large volumes of input and output in a given period of time is called what? A throughput. That's what it is. Okay, so you could say throughput is the large number of simultaneous transaction okay, and extremely large volume of what? Input and what? Output in a given period of time. That's what it is. Okay, so why this is a large number of simultaneous transactions and extremely large volumes of input and output in a given period of time? A supercomputer is designed for maximum processing powers and speed. Okay, whereas a throughput is just distinct mainframe. So please don't get this confused. We'll talk about throughput, or just talking about mainframe computers alone. Okay, mainframe computers alone. Okay, so this is very, very important. Okay, all right. Fault tolerance. fault tolerance. A computer with fault tolerance means it can continue to operate even if one or more of its components has failed. That's what it means. Looking at the A-level past papers, you see they tell you explain what fault tolerance is. They give scenarios about it. But you need to understand that when we talk about fault tolerance, it simply means that even when there is a downtime, it continues to operate. And that's what we're talking about. Okay, so it continues to operate even if the one component, and we talked about this, if you've been with me to this moment, we talked about the fact that when there is, if one of the CPUs are down or there's a fault in one of the central processing unit, it automatically switches to the next one to ensure that there's continuity, even if we have an MIPS. Okay, even if we have that. Now, what do you mean by the MIPS? We're talking about not the MIPS, MTBF, talking about the mean time between failures. Okay, so even if there's a failure, it continues to operate. Now, it may have to operate at a reduced level, but does not fail completely. At least the app opens, you can be able to navigate through. Except in worst case scenarios where you cannot be able to carry out some transactions, but sometimes you can be able to do some things in the app, okay? But majorly it is up and running. It's not a total shutdown, okay? It's not a total shutdown, okay? Now, mainframe computers have the characteristics of being fault tolerant in terms of its hardware. Yeah. Now, why in operation? Okay, if a processor fails to function, what happens to it? Pause the video and tell me the answer. What happens? If a processor fails to function, what happens? Yes, the system is able to switch to another processor without what? Disrupting the processing of data. Now, if you've said that, bravo, you've been paying attention to my class and I'm proud of you. Yes, you should give a like for that. Okay, so the system is able to deal with the software problem by having two different versions of the software. Okay, if the first version produces error, the other version is automatically what? One. Okay, now we're going to talk about the uses. But before we talk about the uses, okay, can we talk about the operating system? Yes, let's talk about the operating system. Okay, I think I have a space here. Let me see. I think I have a space here. Let me see if I have this available space here. I have it. So let's talk about the operating system. Okay. Okay, I think my pens. Let's talk about the operating system. Now, most mainframe computers run more than one operating system at any given time. Okay, and what are the operating system they use? Please let's take note. They use the Z. That's the Z operating system. Okay, they use the virtual machine. Okay, and again they make use of. Okay, let me see. Do this. They make use of let me just take this off. Okay, and they make use of what we call the Linux. Okay, which are all different operating system. They are all different operating system at the same time of the course. Okay, so these are the operating system that they can make use of. Okay, now the OS on the mainframe divides the task into various subtasks. Okay, simply means there's assigning one on a different processor core. So maybe this processor is making use of this operating system, so that way it makes use of operating system. So this one is also making use of this operating system. Okay, so each subtask have been processed. Okay, the results are recombined. Okay, to provide meaningful output. Yeah, to provide what? A meaningful output. Now, this is called parallel processing. Remember we talked about parallel processing. Okay, that is performing more than one task. Yeah, that's because there's more than one operating system. And this is what makes a mainframe far more efficient than a PC. Okay, if you don't know what the PC means, it means personal computer. I know you know, but I just wanted to be sure that you do. Okay, which despite having more than one core these days, has a very limited capability regarding power processing. Okay, but for supercomputer, they tend to just have just one operating system, Linux. But now most supercomputers utilize massive power processing in that they have many processor cores, each one with its own operating system. Okay, Linux is the most popular. Okay, because it is an open source software. Yeah, Linux. Okay, and it's when we talk about open source, it simply means it is free to what? To use. Okay. Okay, so let's talk about okay, we've talked about the processors. Okay, we'll talk about the processor. We're still talking about the CPU. Okay, and one of the major mainframe manufacturers called the CPU complex. Okay, they have many processors. Okay, they also have a heat maintenance with a cooling system that needs to be on ground to ensure that the system is because of the heat that it generates. Okay, so let's talk about mainframe computer uses. Okay, now mainframe computer plays a vital role in the daily operations of many organizations. Okay, of many organizations. Is it health? Is it insurance? Is it airline, etc., etc.? Now, the greatest use of mainframe is in the banking. It can never be overemphasized. The banking sector. Okay, with banks throughout the world using mainframe to process billions of transactions. Okay, the key benefit of mainframe is the ability to process many terabytes of data, which is very useful when carrying out batch processing. Okay, now we're talking about processing of these data in group without any form of without user interaction. That's what we mean. We talked about it in the chapter 1, which is also available in my YouTube channel, so you might want to give it a spin. Okay, and then you can come back. Okay. So the first use right here is sensor. Now, sensor is a term that, when used alone, refers to population sensor, right? Yeah, that's what comes to mind. Now, and a population sensor is an official survey of the people and household in a country. Now, in the US, in the UK, sensors are being carried out to find out how many people are living in the country. For example, Canada, South Korea, Greece, to find out how many people live there. Now, it is used to obtain details of such things like the people's age, the types of employment. Okay, and this type of data has to be processed. This type of data that needs to be processed is enormous. Okay, now the processing of sensor data has been long associated with computers. Remember, in the generation of computer, now this is for computer students, okay? If you're coming from IGCSE computer science, probably you know what I'm talking about. Generation of computer. The first generation of computer was the UNIVAC 1, right? You remember, right? The EDVAC, you put UNIVAC, which was the first computer on general sales to organizations. That should be around when the United States carried out their census. I'm not very good with I'm terrible when it comes to history. But if I'm trying to for the history students, maybe if you also did ICT, you can help me out. I think when they carried out their first census in I think 1941 or 1951. Okay, so please carry out the research and let me know in the comment section. Is it 1941 or 1951? Okay, just let me know in the comment section. Okay. After that, we saw a technological innovation that has seen the production of different generations of mainframe and other development have enabled the sensor agency to become more knowledgeable in the way they process and they manipulate data. Okay. Now, a sensor takes place every decade. Every decade, a sensor takes place. Every decade, a sensor takes place. So, for United States, I wouldn't know the last time. I don't stay in the US. I don't know the last time the sensor was taken. But if it was let's taken like 2010, the next one was 2020, and maybe the next one will be 2030. Okay. Okay, so that's one of the use of what the mainframe for sensor. Okay, just to carry out to know how many people are living and not just the employment status and a lot of things. The next one is industry statistics. Okay, so they're recorded. Okay. Regarding trends in different industries, such as how they process raw materials, how you make your goods in factories, you provide services, okay, and they can include the numbers and names of businesses, okay, also the numbers of employees, the wages paid, okay, some business in certain sectors, okay, of industries need mainframe. Yeah, they do. To process the vast amount. When we talk about just stay with me. When we talk about large amount of data, that's where mainframe comes in, because you need to process an enormous amount of data. Okay, which helps to identify their major competitors. You want to know how is Apple doing, how is Microsoft doing. Okay, how is Amazon doing? Okay, so it shows their competitor shares of the market, the stock market, and their trends in their sales. In terms of the technological market, how well are they selling? What are they doing? How can we model their pattern to ensure that we are right there at the top tier, ensuring that our product is matching these various, we're standing out. Okay, so it helps to identify those products which will compete profitably with other business. Okay, where companies do not feel they need to process their own data, they can obtain reports from organizations that collect the data for them. Okay, I hope that makes sense. Consumer statistics. You want to know the people who are consuming your product. Okay, I'm just gonna say it right here. I know probably I've been waiting to say it. I'm just gonna say it. Apple is topping the charts. Whatever Apple is selling is gold. Okay. You have my comment section right there, and tell me straight up if what I'm saying is a lie. Everybody is keen to have an Apple gadget. Yes, the Microsoft is coming up, and they have some fantastic sales upcoming. Talking about the Microsoft Surface, they will have a the Microsoft Surface Studio, which is powerhouse. But likewise, the Apple, talking about the iPhone, talking about your iWatch, talking about your iPads, talking about the MacBooks, the pencil, the Apple Pencil. It's just an ecosystem. Okay, you did not hear it from me, but Apple is also, they have a project of producing cars. It is called an Apple car. You didn't hear it from me. Okay. All right. Yes. So you want to know It allows businesses to be able to assess the demand for their products, and that's what Apple has done over the years. Demand for the products have skyrocketed to the highest level. The iPhone 15, you saw what happened in the news. For those who were looking at the tech news, saw what happened in Dubai. There was a large crowd for the iPhone 15 launch. A large crowd. So this is what they know. They know that their product is in high demand, and because there is a demand for the product, the test is unsatiable. You're using an iPhone 10. That's okay. I almost feel there's no iPhone 10, Mr. Ijari. iPhone X. Okay. Yes, X. Okay. Okay. And you want to go from iPhone X, it's time to upgrade to iPhone 11. And there's that obsession. Now, there's that obsession of, if you're using an iPhone 11, you want to go for an iPhone 12. If you're using an iPhone 11 Pro Max, you want to go to an iPhone 10 Pro Max. There's that demand, not obsession, the demand for it. Okay, that's how many people tend to or want the type of product that they are selling. They can inform them about the range of household incomes and the employment status of these consumers who might be interested in the product, so that a price can be set. Okay, this data will also inform the business of where the consumer live for local sales. Okay, or how inclined they are to use internet for shopping. People buying it both locally and internationally. It also allows businesses to know how many similar products already are available to consumers. Okay, they want to know, how is Microsoft faring with their mobile devices? Okay, how is the Android? How is Google faring with the Android? I think Google is right there. Google Pixel 8 is out. Google has promised to keep up to 5 years update on their new devices. Okay, so I think it's actually pretty cool for Google to actually come out to make that promises, because oftentimes most of their products that are not having the rate of sales in terms of their statistics, they've just been dead. They kill off projects so easily, apart from the ones that still existed. Of course, YouTube is a high stream income that is feeding you Google over the years. I think the evaluation worth of YouTube is $1.3 trillion. I'm not really sure. You might want to check that out and let me know in the comment section. Okay, so it allows people to know similar products that also exist and what price they pay for them. Okay, for iPhone 15, I think it's $1,999. Why not say 2,000? Okay, they do this all the time. They always they always tag it as difference of 1 cent. Like, okay, I know, right? And you're probably thinking the same thing like me. Like, why just make it 2,000? Like, literally, why not make it 2,000? Okay, so these statistics produce an incredible amount of data, and the organization that produces the statistics are likely to use the mainframe. Finally, transaction processing. Okay, so it consists of more than one computer processing operations, but these operations must combine to make a single transaction. Okay, so each of the operations that constitute the transactions must be carried out without errors, okay, occurring. Otherwise, the transaction will be deemed to have failed. A transaction processing system, in the event of an error, will remove all traces of the operation, and the system will continue as though the transaction never happened. However, if there are no errors, the transaction is completed, and the relevant database is then updated before the system continues on the next transaction. All this, of course, has to happen in milliseconds. Okay, and that's why, remember, we talked about the MIPS. Okay, we talked about it, so who can remind me of it? So it means millions of instructions per what? Second. Okay, that's why it's important to take note in my class. Very important. Okay, all right. Okay, so it's very, very important. Okay, All this, of course, has to happen, like I said, in seconds, and as it seems to the user that the transaction has been carried out immediately. Okay. We talked about those types of processing in chapter 1 as well. Okay. Okay, let's do an example just to portray my point. Let's say you want to transfer a sum of money from one bank to another. Okay, for example, you want to transfer $100, okay, from your bank to a supermarket bank account. To make it simpler, consider that the customer and the supermarket use the same bank. Okay, so there are two operations involved. One that is 100,000 must be subtracted from the customer's account balance, and the other one, $100, must be added to the supermarket account balance. If either of this operation fails, then the transaction will be cancelled by the mainframe. If there's a debit but there is no credit, then it's going to fail. So, or the bank will not be able to balance the book at the end. So there will not be a balance. So that's why the transaction has to be failed. Okay. Okay. I know most of you are asking me right now, Mr. Ajiro, why is mainframe computers so well suited to transaction processing? Okay. I'm catching my breath. I want to answer that right now. Okay. The effectiveness of the transaction processing system is often measured by the number of transactions. Yes. Okay, I'm going to say it again. Okay. The effectiveness of a transaction processing system is often measured by the number of transactions it can process in a given period of time. This is why the mainframe computers is so well suited, because of the effectiveness, because of processing of the vast amount of data. We know, yes, that the mainframe computer, I've said it over again in this video, it can produce what? It can perform hundreds of millions of instructions per what? Per seconds. So the system must be continuously what? Available during this time when users are entering transactions, and the system must be able to deal with hardware or software problems without affecting the integrity. I want to use that keyword, the integrity of the data. Okay, transaction has to be carried out, okay, and still able to deal with the hardware or software problems without affecting the integrity of the data. It must also be able to, one, add, two, replace, or update, okay, hardware and software component without shutting down the system. This is why mainframe computers are key. This is A-level, guys. This is not O-level. This is A-level. We have to go deep. Yes. So buckle up. Okay. So this is, okay, buckle up for it. Okay. So with this ability to transfer processing from one core, we'll talk about one core by now. You should know that's one processor or one CPU. Okay. To another. So to answer your question and to give conclusion to your question, the mainframe is more than suitable for transactional processing because of the effectiveness of the transaction processing that is often measured by the number of transactions it can process in a given amount of time. Okay. Are we not loving? I'm loving this. I'm loving this class already. I know you're loving it already because I'm loving it, and we're still having fun, and we're still going. Yes, we're still going. Okay, we're still going. Now let's talk about. We've talked about the mainframe computer users. Okay, let's talk about the supercomputer users. Okay, the first use of supercomputer that I can think of in this class was used in national defense. They were used in designing of nuclear weapons. That's the first one I can think of. Okay, you can go through and maybe go through your textbook and then let me know other ones too, and just drop it there right here in the comment section. Yeah. Now, supercomputers have become important in the field of scientific research. Now, when we talk about scientific research, and this is my first point, my first issue right here, we're talking about quantum mechanics. Yeah. Oh, you're A level. I'm not using small words for you. We're going using big words. Okay, big words. All right. This is your face right now, so just go with it. Okay. Yes. Okay. So yes, scientific research, and they have also become essential for weather forecasting. And there are also other uses, and other uses. We're going to talk about them. Climate research, etc., etc. Okay. Now, let's talk about the quantum mechanics. Now, when we talk about the quantum mechanics, like I said, scientific research is the study of behavior of matter and light on the atomic and subatomic scale. Okay, I'm not a chemistry teacher. Okay, if you've been going to my YouTube channel, you know that there's a chemistry teacher called Mr. Gideon. Is a fantastic teacher. I can tell you, it's good with this chemistry stuff. Okay. Okay, it's good with this chemistry. I just ICT, just ICT. So, just computer. Okay. Okay. So okay. So it's a study of it. A study of the behavior of matter and light on the atomic and subatomic scale. Okay. It attempts to describe the properties of the constituent part of an atom. Okay, we'll talk about the atom. Remember, we have, I'm just trying to remember my chemistry days. We have the electron, proton, and neutron. Okay, I think proton is positive, electron is negative. Just let me know in the comment section, okay? Okay, and how they interact with each other, okay? They don't have to behave in the same way as larger bodies, okay, which will be the law of physics. Okay, which will be the law of physics. That's, yes, you see that as well also in physics. Talking about physics, there's a YouTube channel called Physics for Everybody by Mr. Debwale. It's a fantastic O-level, E-level teacher when it comes to physics. Yep, it's right there on my YouTube channel. Check the community, you see that. Okay, so you don't need to understand quantum mechanics. Okay, but it's very important to realize that there are very large numbers of calculation. Okay, you don't have to, okay, if you did not do physics, you did chemistry, no worries. Okay, forget about all the behavior of matter of light, atomic, subatomic scales, atoms, proton. You don't have to worry about that. But what we are simply talking about here is that there it is important that we need to understand the fact that very large number of calculations which require great accuracy and thus require the use of a supercomputer. Can I go a little bit deeper? The Juden supercomputers in Germany, although it's now been decommissioned, was used by a team of physicists to calculate the difference in mass between a neutron and a proton, as well as predicting the makeup of dark matters. Although it had a maximum performance of 5 petaflops with 558 or 59,000 cores, okay, it's been replaced by the dual supercomputers, which is the performance of more than that of the Jupyter, or the sorry, not the Jupyter, but the Juquin. Yeah, Juquin. Okay, so the Jewel's supercomputer now has a higher performance of it. Okay, the Juquin has I think performance of 5 flops. This has a performance of 12 petaflops. Okay, with double of the cores. Okay, so it's important that it is used to process large amount of calculations. Okay, weather forecasting. Weather forecasting is based on the use of very complex models. Okay, Data from the sensor at weather stations around the world is input to the model, okay, and then many calculations are performed. Okay, records of previous weather conditions have also been calculated over a long period of time to see what happens in this time of the year. Is it going to be rainy? Is it going to be sunny? If there's going to be a rain, what day and what day? So it's something that has been consistently being performed, predicted to a certain level of accuracy. Using the past weather readings, the computer examines similar patterns of weather to those being experienced at the moment, and it's also being to predict the resulting weather. Okay, variables such as we use the atmospheric pressure, humidity, rainfall, temperature, wind speed, wind directions are recorded using computerized weather stations, okay, around the world. These readings, together with observations from the radar or from the satellite surrounding the space and information from ships, aircraft, help the supercomputer to produce what we call a third dimension model of the Earth atmosphere because of the complexity of the calculations and very large numbers of them that needs to be carried out. Okay, so they run effectively on the supercomputer, and that's why we need it. Climate change is also an extension of weather monitoring as well, because climate is measured over a long or a much longer time scale. Okay, a much longer time scale. Okay, so data collected over several decades can now show the trends of different variables, okay, over time. Okay, for example, you want to know the levels of nitrogen dioxide, sulfur dioxide, and etc. Okay, so rivers are monitored, measuring different variables such as the temperature, the pH, the dissolved oxygen, and so on. So it's important. So we use it for the climate research to see what are the changes in the climate. Okay, also to see interactions where the Earth system can be described in a mathematical term. Okay, they're very in terms of the weather forecasting. There are so many variables, mathematical variables to it. Okay, which are also collected. Complex calculation which needs also to be carried out. Okay, we can rely on the computer model to help us understand how the system works. Climate is one component of its Earth system. Okay, and only supercomputers are able to run models to represent the interaction between the component of the system. Okay, let's look at advantages of mainframe computers. Mainframe computers are very reliable and rarely have any system downtime. Now, this is one reason why organizations such as banks, banks is going to be my citation in this class, okay, use them. Many other systems do fail at some point and then have to be rebooted, or okay, let's use the common term word, restarted, as most people who use their laptop and PCs will know, right? Okay, so it's important. This is why mainframe is very important, because it's reliable. Okay, they rarely have it because of the so many cores they have. The next one, hardware and software upgrade can occur while the mainframe system is still up and running. We've talked about this, but this is all what I've said earlier on. I'm just picking it out as an advantage. Okay, just in case you're going through your A-level past papers and then you see questions like this, you now know how to portray your points. Okay, mainframe computers as well are getting faster and more powerful every year. There are new versions of it, and are completely outperforming PCs, laptop, and other devices. So they're getting faster. Okay, that's a point. So you can write that down. That's a point. The next one is mainframe can deal with what? Huge amount of data. that some organization will need to store and process. Okay, now most organizations that use mainframe will find it exceptionally difficult, okay, to transfer all the data that they have stored on their current mainframe to an alternative system. You find it difficult because of a mainframe ability to run different operating systems. So you cannot just transfer to any computer. It's very difficult. Okay, so it can cope with data coming in varieties of data format or database format, which other platform will find it problematic. Okay, so it's very, very important. Also, final point is mainframe have strong security or stronger security right there on the screen than other systems which have what? Which have complex encryption system and authorizations procedures in place. Okay, let's look at disadvantages of mainframe computers. Let's look at it. Disadvantages of mainframe computers. One is mainframe computers are expensive to buy. It can only be affordable by large organizations such as multinational banks. Okay, there's also a high cost for the personnel acquired to run and maintain them. Okay, large rooms are also required to house the system, which is not needed with other systems. Mainframe computer is not just a PC. No, it's not just a PC. You need a large room to be able to put your mainframe computers together. Okay. Also, if you want to talk about the fact that many organizations are now migrating to cloud-based systems, yeah, it's happening. Okay, we have to talk about it, even if it's not it's out within the scope of what we are learning tonight, what we are learning right now. So they don't have to buy their own system or hire an expert required. Okay, so they are migrating to a cloud-based system. So it's the cloud-based system that is now handling this complex set of data for them. Okay, so the software required to run even the mainframe system is also quite expensive. Okay, so yes. All right. Now it's time for advantages of supercomputers. Okay, let's talk about it. Supercomputers. I think supercomputers is the fastest. We've talked about it. It's the fastest processing computers. Yes. Okay. Although it's not like the mainframe computers, we've seen computers because mainframe has multiple cores. The supercomputer does not. Although it has a lot of power processing. Yes. I know. Okay. This is A level. This is not O level. It's a lot of big terms we're using to portray our points, and it's very, very important that we have the scope of it. So it's really the fastest. Okay, it's really the fastest because it can be able to process a lot of data at a very, very fast rate. It's very, very important. But also we need to also note this. This is in my second point right here on your screen, is the fact that supercomputers are less fault tolerance than mainframe. And they are less likely to recover as quickly in the event of one component failure. Yeah, one component failure, which is where I think this is where the mainframe computer shines very well. Okay, this is where the mainframe computer shines very well. Okay, because yes, we know that the supercomputer have one operating system, whereas the mainframe computer have more than one. Okay, so this is why it has less fault tolerance. Okay, this is why it has, and are down more often than the mainframe, although not as often as other systems. So why it is not like the mainframe, it is still better than other systems. That's what I'm trying to say. So it's not like a disadvantage, because I know most of you will be asking, Mr. Ajiro, I know you're talking about less fault tolerance. Is that not a disadvantage? I know. Okay, I have to talk about it in mainframe, in comparison to mainframe. I have to. Okay, but when we look at in terms to other computers, yeah, it's better. Okay, and my final point on advantages is the fact that in fact, is the fact that supercomputers use massively parallel processing. We've talked about it, which makes them more powerful compared to parallel processing of mainframe. Okay, and much more powerful than other PCs. This is, we've talked about this, but there's a need for us to itemize it and talk about it in terms of advantage of supercomputers. So they can process more than one task at a very fast rate. Okay, at a very fast rate. What are its advantages? Expensive to buy, okay, and install, and they are more down. They have a more downtime or a fault tolerance than the mainframe. Okay, all right. Okay, we are done with the hustle. We're done with the most complex part. We are now in the very easy part. Clap for yourself. Okay. This was, oh, finally, Mr. Jaro, something we can relate to. Okay, I know. Something we can relate to. System software. Now, whether you did IGCSE, ICT, you did IGCSE computer science, you did Excel. Well, the good news is we all know what it is. Okay, for O level, IGCSE, ICT, you will see this in types and component of the computer system, chapter 1 of the textbook, and you see that it's part of it on that hardware, software, and then we have to talk about the system software. Okay, we have application and we have, so we're talking about system software. Now we'll talk about system software. They refer to programs that can run and control a computer hardware and application software. Yes, so they refer to what? Programs that can run and control a computer. Okay, a computer hardware and application what? Software. Let's talk about examples. The examples of them are your compilers, your interpreters, your linkers, device drivers, operating system, utilities. We're going to talk about all this, okay, very quickly, because it's something that we know. If I need to dwell more on it, I will do that, okay, because we're having a very good time together. So let's talk about compilers. Okay, most softwares, right here on your screen, most softwares that run on computer is in machine code, and this is true. Okay, which is stored in binary form within what? The computer. Okay, machine code consists of instructions that only the computer can understand, and each instruction is actually a number written in binary. Okay, it's written in binary. Okay, unfortunately, programmers who write the software for computer users find it difficult to use machine code for programming purposes. Okay, in the early days, okay, we felt necessary to develop languages with programmers which programmers could understand and was close to the use of everyday language. This was the concept of developing these languages, something that programmers can be able to relate with instead of going to learn so many languages. And we have examples of them. We have Fortran. You remember? Okay, maybe ICT students will not be able to remember this, but computer science definitely. Remember Fortran, COBOL, LIPS. Okay, I'm saying a lot. What is Fortran? Formula translation. Okay, is a formula translation. Now the formula translation, okay, which was the first high-level language to be developed, it was very technical, mathematical in nature. Okay, Fortran is really used these days. Do we still use Fortran? No, it's really used these days. But it still remains popular, okay, for simulating large physical systems, okay, such as modeling of stars and galaxy, etc., etc. But still, it's out of date, right? Okay. The next one is COBOL. Okay. Pause. Let's just pause and go find out the meaning of COBOL and come back to it. Have you done that? Okay. I'm just gonna give it to you right there. It means common business oriented language. That's what it means. Common business oriented. So the CO here means common. B means business. O means oriented. L means language. I know, right? So the O should have been small, should be in a lowercase. I know, but I don't make up those words, right? Okay. So it was developed not long after Fortran to help with businesses. Okay. Unlike the Fortran, which relied on mathematical equations, COBOL tend to use simple expressions such as what? Subtract money from account given balance. Okay, I think that's really easy. Okay, rather than equations like bal equals to arc. Okay, let me just, so unlike you have something like this, let me just do that. You have like bar equals to arc. Okay, and then maybe you have a dash here, like that's Fortran for you. But you don't have to do that for COBOL. You just have like, for COBOL, like I said, you have like subtract. Okay, you can have subtract your money. Okay, then you have from. Okay, account. Okay, then you have given, and then you have balance. That's COBOL for you. Very simple. Subtract money from, yeah. Okay, kind of like SQL really. Okay, yes. Okay, so this is very important. Actually, I can clean this. Yes, clean. Hope we're having fun in this class. The next one is LEAPS. And LEAPS talks about list processor. I think I have to just write this down. LEAPS here talks about list. So this means list. Okay, this right here. Okay, then we have processor. Again, I'm not the one that came up with those words. I don't know the concept about it. You would think that the list means L for something, I for something, S, but it is what it is. Okay. Okay. It was also one of the early high-level language. Okay. In LEAPS, simple statements often start with mathematical operators, such as this. Okay. I'm just going to write it down. I think if I remember, we have plus 4 8. Okay. So which would calculate as 4 plus 2. So the operation is at the beginning. Okay. So the operation for LEAPS is at the beginning. So if you want to add something, you use it here. At the beginning. Okay. Yes. Okay, so LEAPS was extensively in the early years of AI, but apart from its use in association with CAD, it's rarely used today. Okay, it's rarely used today. I think I can just clean this up. Let me clean this up. Okay. Clean this up. Okay. Okay. I need to just explain that so it's easy for you. Anytime you say it. Okay. All right. Okay. Although for most modern languages, it's done using C++, C Sharp, Visual Basic, or Pascal. Okay. Now, what is a compiler? A compiler is, let me write it down. A compiler, I think I can write compiler. Okay. Of course, it's a software, okay, or a program that processes statement written in a what? High level what? Programming language. Okay, and convert them into what? machine what? Language. Or code that a computer can understand and can execute. That's what they are. Okay, so in other words, it translates high level what? Language program from a source code into what? An executable file called what? An object code. Okay, interpreters. So interpreters translate high level language statement or high level language program or line. So they translate high level language program one statement or one line at a time into what? An intermediate form, which is then what? Execute. So it can translate the program until the first error is made. So it interprets or translate them what? Line by line until what? There's an error. So it simply means that the errors are located by what? The programmer, exactly where they occur. An interpreter has to do these conversions every time a statement is what? Executed. Okay, so an interpreted program can be transferred between computers with different operating systems because it remains in the form of what? Source code. But it needs to be translated in each computer or in each computer is moved to. Every time you move it to another computer, it needs to be translated. Okay, this takes more time with the compiler that just translate the whole program regardless of the processor or the operating system. Okay. So let's talk about the advantage and disadvantage of interpreters compared with compilers. So advantages and disadvantages of interpreters compared with compilers. So let's look at this. Advantage is while a program is being compiled, if it is a major application and takes a long time, the programmer has to wait doing nothing before they can correct an error. With an interpreted program, the programmer can correct the error as they are found. Okay, yes, this is another advantage of an interpreter because if you look at it, okay, you have to compile the whole program to know if there's going to be an error or not. Okay, for disadvantages, the execution process is slower for an interpreted program, as each statement must be translated before execution. So it has to translate line by line to ensure every line of code is properly correct before you can run the program. Okay, but when we look at the compiler, once that's been compiled, it executes in one go. Okay, the time it takes to compile a program can be long, but once it's compiled, it does not have to be translated. Okay, which compares favorably with an interpreted program, which has to be translated every time it runs. Okay, hope that makes sense. Debugging is easier with an interpreter. Yes, as error messages are output as soon as there's an error in the statement, especially if the program is very, very long. Okay, so it's very, very easy. Okay, because it shows you the line and then you go to it and then you can correct it immediately before you move on to the next one. So it gives the programmer an opportunity to correct the error there and then. Okay, with the compiler, all the error messages are just outputted at once. So like you keep doing one, you keep doing the other one, you keep doing the other one before you can process and get it correct. A disadvantage here is the fact that with an interpreted program, the source code must always be available, which can lead to software copyright, infringement, or intellectual properties, right, being at risk. Okay, it has to be available. You have to go back to the back end and all of that, and before you know it, people could just copy it. Okay. Okay. Here we have an advantage. A compiled program will only run on a computer with the same operating system as the computer as it was originally compiled on, whereas an interpreted program will still be in its original source code and will work on any system with this appropriate interpreter. Okay, so for compilers, you need to have the same operating system to work on it, but interpreters is still in the source code. You have not compiled it yet. This simply means that if there are no available softwares or available files for that particular program that you have compiled, it's not going to work. You still need that same operating system to be able to work on it. But for another advantage of the interpreter is the fact that okay, just to portray my point on this, if you compile the program using Windows 10, you have a lot of files on Windows 10. If you use it on Windows 11, it's not going to work. You need that same operating system. I hope that makes sense. Now, the next one is compiling a program use more memories than interpreting, than interpreting it. Okay, as the whole program must be loaded before translation. Whereas with an interpreter, only a few statements of program have to be in memory at that given time. But for compiler, all the program will be in memory. Okay, so this means a small piece of code can be tested to make sure that they work before continuing with the rest of the program. I know you're having fun already, so stick with me. Okay, don't sleep on this. Okay, we're getting there. Okay, let's talk about the next one. Linkers. Okay, so what are linkers? Now, linkers has its full name as link editors. So it's a system program that combines, what's this? Object files, okay, or modules. Object files or modules that have been created. Object files or modules that have been created using a compiler into one single executable file. Okay, so it is a system program that combines what? The object files or modules that have been created, okay, using a compiler into one executable file. Most programs are written in modular forms. What do you mean by modular form? They are written in just small piece, and they will make them to be a whole. Okay, that is to say, a number of programmers will write separate. It means not some programmers are writing separate piece of code. Okay, those codes are called modules. Okay, that forms the required program when combined, which has the advantage of saving time. That if one person wrote the whole block of code, okay, although it is still possible for one person to write all the modules, but if there's an error, okay, only that module has to be corrected. Okay, so in short, a linker is used to combine different modules, okay, different modules of object code into one single executable program. Okay, it could be that a large program can only be compiled in small parts because there might not be enough RAM to hold the whole program and the compiler program. So the part of the program can be stored on backing storage, and then one at a time each part is brought into the RAM and then compiled, and the resulting object code is then saved to the backing storage. Okay, and then compiled. Okay, device drivers. So in device drivers, it is a small program that enables the operating system and application software to communicate with the hardware device. Okay, I have a printer. Okay, now for the printer to be able to work, I need the device driver. I need that small program that's going to enable the operating system and the application software, which is the application, the device driver software, to be able to communicate with what the hardware, which is what the printer that I have. I don't know if that makes sense. Okay, so so the application will tell the printer driver, and the printer driver will tell the printer. I come again. So okay, this simply means that the application tells the printer driver, okay, and the printer driver tells the printer. Okay, so it allows the user to be able to have control of the device. Okay, all right. Operating system. Operating system is a system software. Now, before an operating system, before an operating system is loaded, the computer has to boot up. True or false? True. Okay. Now, booting up a computer is starting up by loading what we call the BIOS. Now, let me explain what the BIOS means. It means basic input and output system. And this BIOS is stored in the ROM. Please, I want you to follow me on this thing, okay? And it's stored in the ROM, and the BIOS for the computer which execute during boot up. Now, the onus of the BIOS is to check various devices if they are present. And once it's present, the operating system is now being loaded to the RAM. Okay, what's an operating system? Okay. Now, an operating system is a system software, okay, that manages computer hardware and software resources, as well as interacting with device driver. I think this is the most, for A level, I think this is the best way to put it. I don't want to give you a very simple definition of like, okay, no, don't tell me the comments to give you. No, this is the best, because this is what will fetch you your mark. Okay, so it's a system software that manages, watch this, the computer hardware and software resources. So it manages the computer hardware. It also manages the software resources, as well as also interacting. It's not a complex definition, as well as also interacting with what devices. So it manages the computer hardware, the software resources, as well as what interacting with what the device drivers. Okay, some of the device drivers are separate to the operating system, but are often included by the provider of the operating system. Hope that makes sense. Okay, so the operating system acts as an interface between the user and the computer, as well as supplying, watch this, important utilities for managing the computer. Okay, for managing the computer. Now, okay, what's the utility program? Okay, I know most of you are asking, Mr. Ajiro, okay, what's the utility program? A utility program is the type of software that assists users in one, controlling, maintaining the operation of a computer. As simple as that. Okay, that's what it is. I come again. A utility program is the type of system software that assists the user in controlling, maintaining the operation of a computer, its devices, or its what? Software. So anything that assists the user in controlling or maintaining is a utility what? Program. Antiviruses. Okay. They're utilities because they assist in controlling what? Against viruses. Disk defragmenter. They assist against ensuring that your hardware is what? Is performing in optimal performance. Disk cleaning to ensure that your hard disk drive is healthy. Okay? So we see all this. Okay? We see all this. Okay? Alright. So again, I've talked about this. Okay? About the utility software. Like I said, it's a type of software that is needed to help maintain a computer system. Okay? And these are the basic utility programs that are supplied with the operating system, most of which help to just manage files and other storage devices. Okay, we're going to look at the types of utility software. The types of utility software. Okay, so let's talk about the types of utility software. The first one is structured of hard disk storage. Now, a hard disk consists of several platters. Those platters means individual disks, which each side or surface of the platter, top and bottom, having its own read and write head. Now, if you check your hard disk, it has that read and write head. Okay, so the read and write head moves across that platter. That platter means the disks floating on the film of air, and when they stop, they either read the data or they write to the surface. Okay, I don't know if that makes sense. Okay, there's some things I'm going to talk about here. is the fact that each surface is divided into what? Several tracks. And each track is divided into what? Sectors. The tracks are in the same position on each disk. Okay, so the tracks on the top platter with the tracks exactly below it. Okay, as much as possible. Okay, so it's very, very important. Disk defragment. Okay, when a file is stored on a disk, it may consist of several blocks. There may not be enough blank or empty sectors next to each other to store all the blocks together. Okay, which means that they have to be spread out across the disk. The file is now sent to was fragmented. When data is no longer needed, it is deleted from the disk, which leaves some empty sectors. Do you understand? It leaves some empty sectors. Defragmented software is used to organize the data on the disk by moving the data blocks around to bring all parts of the file together so they are what? Contiguous. Okay? Data compression is the modifying of data so that it occupies what? Less storage space on a disk. Okay? Less storage space on a disk. There's no way to go around this. This is you're just compressing. We have lossless compression. Okay, that is the file is converted back into its original state without the loss of a single bit or whatever. Okay, we have the lousy compression and all about that. Okay, we'll talk about file compression, which is in chapter 11. God will help us to talk about all this so that you can have all these resources right here on my YouTube channel and you can have a very, very good personal study. Okay, we also have backup. We'll talk about backup. Is a program that is used to keep copies of files from a computer or copy the content of a server word back in storage. The backup is an exact duplicate of the file. It can be used for restoring what? The original files. Should the original file become corrupted or deleted accidentally or deliberately, okay, the backup software allow you to be able to select the time and type of backup they want, and then you can get those files back. File copying. Okay, this is what? Creating a duplicate of an existing file. The copy we have the exact content as what? The original. That's file copying. The numbers of ways of file copying utility works. It could be in CLI, where the user will type some form of copy command which contains the same name of the file as well as the destination directory or folder. Okay, with a GUI, which is what everybody has. Okay, the user can have a variety of ways of doing this. One of the simplest way is to have both folders or window present on the screen, and then you can just right click over the file and then select copy, and then you drop down the right click to the destination folder, and then you have that. Okay, so that's file copying. So you are creating a duplicate of an existing file. You are having the exact replica of that file in another folder. Deleting. It's a utility now. Of course, yeah, it's A-level. It's utility. Okay, we'll talk about all this. It's a piece of software which deletes the pointer that tells the OS where to find the file. Okay. Okay, so that's what it is. To delete the pointer that tells the OS where to find the file. Okay. I think there's no need of stressing the fact of deleting anywhere, anytime. Okay. Antiviruses, as the name suggests, can be a program or a set of programs whose function is to detect and remove viruses. Okay, so we are now in the final part of our lesson objective. So let's look at it. Okay, sorry, let me have it here. Let's go back to the first part of it. We'll look at our lesson objective. So here you can see that the use of what? Custom written software, okay, and the off-shell what? Software. Okay, so let's go back to it. So we're now here. Now, for the custom written software, this is a software that has to be specially written for a particular task and is developed for a specific company or business. Now, okay, so let me explain this. How do I start it? Okay, when a company installs a new computer system, it will need to obtain application software, right? Whether it is for producing word processed documents, keeping databases of employee records, or producing invoices. However, many companies can discover that they've discovered that finding the most appropriate software for them can prove difficult. If a wrong decision is made, they may need to keep modifying their systems or even have to abandon the software and start again. So generally, what they do is they tend to do a custom written software or off-the-shelf software. Okay, so you can either buy off-the-shelf. The off-the-shelf is one you buy, or you can tell a programmer to create a custom written software. That's what I simply talk about. So that's why some organizations, they just need you to just create a program that will do a particular task. So again, that's why we looked at the fact that if a company with the new computer system is a large company, it might want to employ a programmer to write software specifically to solve a particular problem or provide for a specific need. Now, there are reasons why it want to do this. Let's talk about the reason why I want to do this. For example, it may need database to be designed which require specialist programming skills. It may also need a website to be created which would want to be tailored to their own needs. Instead of just getting a template, you want to create it from off the scratch. Okay. Once the software is written, the company will own it and will be able to sell it to other companies. So these are softwares that you create from scratch. You have intellectual property or you have claim towards the software, and you can sell it to other people to use. Yeah. It's not complex. It's not difficult to grab. Okay. You have a problem, or large organization. Okay, we want to do this. Okay, why not develop an enterprise resource planning or an e-commerce software for our organization? Instead of we buying an off-the-shelf software, we can just create our own to suit our needs, and we can also sell it off the shelf. Now, okay, don't look the picture. The picture try to explain what I'm talking about. This is software which already exists and is available right away, ready for use. So if the company with the new computer system is a smaller company, this is for small, larger companies will want to create theirs. We've seen as custom written softwares. Smaller companies want to get off-the-shelf software. Okay, so if company with the new computer system is a smaller company, it may turn to one of the large software companies that already produce business software packages. For example, if you need invoicing software, there's also a firm you can buy it. Accounting software you can buy it. Payroll software you can buy it, which are available to business organization and even for the general public. Such program may provide features that many users want, such as text editing, accounting functions, mail merge. The drawback is that in trying to cater for a wide range of users, there might be substantial numbers of features that the purchase company does not need, such as trigonometry functions or engineering functions, etc., etc. Okay, the software therefore need to be adapted for the company's own specific need, which can mean it occupies a large amount of storage space. Unlike the custom written software, it will not be owned by the purchasing company, and even if adapted for it, it will not be able to sell it to other. So they might just design it to your needs, but you can't own it. Okay, you can't own it. Let's talk about the advantages of custom written software and advantage of custom written softwares and off-the-shelf software. Now, for the advantages, custom written software is designed specifically for the task and will meet all customer requirements. It will not need to be adapted. Okay? It will not need to be adapted, unlike off-the-shelf software, which may be difficult to adapt to the particular use the customer requires, because it just need to meet all the customer requirements. Its advantage is that the customer will have to pay the programmer to write the program, which will have to be written specifically for the task, and this will cost more if they are buying, if they were buying off-the-shelf software. Off-the-shelf software is cheaper to buy because it's mass-produced. Instead of one customer paying for the development, there are several customers paying for the software company, thereby indirectly contributing to the development cost. If the software does not meet what the customer wants, obviously the software can be made by the programmer who is readily available. For its advantages, because there will be only one programmer or a small team of programmers, customers may find it difficult to get support if anything goes wrong. With off-the-shelf, there are likely to be what? Internet forums, live chat, okay, online help, as well as telephone helplines with operators who will be experienced with all sorts of queries other customers have made. Off-the-shelf, another advantage is that off-the-shelf software may have features which are not necessary for the customer, okay, but custom written software will not have any unnecessary features. Off-the-shelf software may not have all the functions the customer need, but programmers will make sure that these are included in custom written software. Now, for its advantage, it takes a long time to develop the software since the programmer will be starting from scratch, whereas off-the-shelf is available immediately because it has already been written. There's also the likelihood that a lot of time will be spent having meetings with the programmer to tell them that what will be required of the system. Okay, programmers will know what the current system is and will be able to make sure that the software is compatible with it. Unlike off-the-shelf, which may not necessarily be compatible with the hardwares or operating system currently being used. There might be settings within the off-the-shelf software that cannot be changed. It can't be altered. Okay, but in the custom written software, it can. For disadvantages, there might be more bugs in custom written software, which is true, as it may not have been tested as thoroughly. Often the tests that are carried out are those which the programmer thinks are necessary based on how they think the software will be used. Okay, which may not be accurate. Okay, so off-the-shelf is usually tested rigorously, so it is highly unlikely that there will be any bugs in it. Okay, it will be used many times because it has been used many times already, so any bugs that were present have been discovered and removed. So that is another disadvantage in custom written software, because you just keep discovering bugs that needs to be troubleshooted, that needs to be worked on, and etc. etc. Finally, user interface. When we talk about user interface, okay, this means or the process by which the computer system interacts with the user. It enables the user, with the help of input devices, to communicate with the computer, and then via the OS communicate with a piece of software or any output device. Okay, so what I'm trying to say here is, when we talk about user interface, is a platform, okay, where the user can be able to interact. Okay, so you're interacting with the help of what? Input. Okay, you're communicating with the computer, okay, via the operating system. Okay, you're also communicating with piece of software or any output device. Okay, now a good user interface is one that allows you to perform these communications without encountering any problem. It needs to be user friendly. It should also be intuitive. When we talk about something that is intuitive, it's not something that is difficult to comprehend. That's what intuitive means. Okay, users should also be able to predict what will happen if they take certain action. For example, if a button on the user interface looks like a button in real life, what do I mean? On and off button. If you click on it, it means what? It will go off. Okay, so there are four major interfaces here. We have four major interfaces here. Let's look at it. One, we have the CLI, which is the command line interface. Two, we have the GUI, which is the graphical user interface. Three, we have the dialogue. Okay, the dialogue interface. Okay, four, we have the gesture base interface. Now, this is something I've talked about in the O level. Okay, I've talked about it. You see that in types and component of the computer system in chapter 1 in the O level. But since this is A level, we still have to talk about it. And we still have to go deep into the surface. Not just scratching the surface, but we're going deep into the surface of it. Okay, so stick with me on this. I think I can clean this off. Okay, let me clean this off. Okay. All right. So let's look at the next one. The first one is the command line interface. Now, the command line interface is a means of interacting with the computer using commands in the form of successive line of text. Now, normally a prompt will appear on the screen on which the user will respond by typing a command. Okay, you have dir, which is the directory. You want to see how many folders that you have. Okay, now the output from the computer could be to produce a list or take some other actions. Okay, so for example, I have my command prompt. I'm going to use my command prompt as a good example. So right here, I'm just looking at my directory. I want to look at my directory right here. Now, this directory means I want to know the folders are available in Ajiro. Okay, so these are the folders that I have, even the ones that are hidden. Okay, so for me to do this, these are the folders that I have available. Okay, so to do this, there are so many commands that you need to understand. Okay, so to do this have I can change directory to what I want to change to, maybe to video. You can see that. So if I do on directory, it's going to show the videos I have here. I have screen recorders, canvas, how to do this for my factory, Ajiro Tech tutorial videos. They're all there available on my YouTube channel. So yeah, okay, so you need to understand the command. That's what they are. Okay, so in the early days, the CLI was the only way a user could get the computer to run software or carry out tasks. This type of user interface is rarely used today except by software developers, system administrators, or more advanced users. Okay. All right. Graphical user interface. Now, for graphical user interface, now when CLI was introduced, commands has to be typed in correctly with any misspelling potentially causing the system to fail to perform a desired to not give you the output you're looking for. Now, this made the interface clumsy and confusing, because if you make a lot of errors, it gives you, it's a lot of confusion right there. Okay. Now, there was a need for a less inefficient means of communicating with the computer, which resulted in the creation of the GUI. Now, instead of typing in commands, the GUI used windows, icons, and menus and pointers, collectively known as what? The WIMP. It's right there on the screen. To carry out what? Command, such as what? Opening, deleting, and moving files. Now, technically speaking, a WIMP interface is only a subset. Okay, this is something I did not talk about in the O level, and I'm talking about right here in the A level. Is only a subset of the GUI and requires input devices such as keyboard and mouse. Whereas other types of GUI use different input devices such as what? Touch screen. Stick with me on this. Okay. Now, so you can see right here that we have the touch screen right here, right? Okay. Now, a user can double click on an icon, okay, which could represent a file, a folder, an application, and open it. Okay, so right here you can see that. Okay, so I have a touch screen. This is a touch screen for me. The touch screen laptop, so it's easier to do that. Okay, which could represent that. Now I can also right click on it. Okay, and I have other features for it as well, other submenus for it. Okay, so that is why I said that is a subset. Some will require a keyboard and a mouse to interact. Some is just a touch screen. Okay. Now, dialog interface. Dialog interface. A dialog interface allows a user to communicate with a computer or a device using their voice. The computer is able to use speech recognition software to convert the spoken words into commands it can understand. Many cars have a system whereby the driver is able to control their phone or radio without touching them. For example, the driver is able to initiate a phone call by saying, hey Siri, or switch a particular video channel, and sorry, that's my Siri. Okay, I called hey Siri, and you like, okay, so maybe I don't do that. Okay.
I didn't get that. Could you try again?
Okay.
By the way, if you have another request,
okay.
you don't need to say.
That was my Siri. So okay, so that shows you what I'm talking about. Okay, so yes. Okay, so that's it. Okay, so you're communicating with the computer with your voice. Okay, now the user is able to load and run software packaging and file by speaking into a microphone and saying these commands. The computer or device responds with spoken words after the required text have been converted into speech. Okay, it requires the device to learn the way the speaker talks by asking the user to repeat certain sentences until it has learned the way they speak. It can, however, become quite capable of understanding simple commands. Noise, we have talked about noise in the background, while the user is speaking, and the ability to recognize only in limited vocabulary can cause problem. This is its advantage. Okay, so right here you're wondering, what's this image all about? This is Amazon Alexa. Yeah, Amazon Alexa. Okay, so let's get the next one. Gesture-based interface. You can see that this guy is playing a game using his hands. Okay, so a gesture-based interface is designed to interpret human gesture, okay, and convert this into what? Commands. That's what a gesture-based interface is. Okay, so a gesture-based interface is designed to just interpret, okay, human gesture and convert this into what? Command. Gesture can be made with any part of the body, but it's usually with the face or hand that makes the gesture the computer can interpret. Okay, the face or the hand. Okay, so you're interpreting the interface. The gesture-based interface is designed to just interpret it. Okay, as much as possible. An example of where this type of interface is used is smart homes. When a gesture can turn on the light, you do like this, the light is on. For example, in the area of IT, a gesture can be said to have any physical movement, large or small, that can be interpreted by the computer. Example could be a pointing of a finger, nodding of the head, or wave of hand. This type of gesture can be understood by a computer, but first of all, a camera in conjunction with an infrared sensor detects the movement being made in front of it. So right there's the camera and there's what? An infrared sensor. Okay. So please, this is very, very important. And lastly, let's talk about the advantage and disadvantage of these types of user interface. Let's talk about it. It's important that we talk about it. Users with disabilities, okay, may not be able to hold a mouse or click it, right? So a GUI may not be a suitable user interface for them. They may not be able to type using a keyboard, so CLI will be inappropriate. They may not be able to control the movement of their limb accurately, so a gesture-based interface will be unsuitable. In this instance, a dialogue-based will be the best type of interface for them to use. Let's talk about disadvantage. Despite the potential, or another advantage, which we'll look at it, despite the potential right here, despite the potential advantage of dialogue interface, if there's background noise, okay, now that's the disadvantage of what we're talking about. It's a background noise when the user is speaking, the computer might misunderstand what is being said, which is not a problem when you're using other types of what? Interface. Okay. Let's look at the second one. Some types of user interface will be inappropriate for hygienic reasons. If a user, for example, involved in a food service industry, then touching a mouse, a keyboard or a touchpad or a touch screen may be inadvisable while working. So a GUI or CLI will not be stable for them. However, they might be able to make gesture and speak. So a gesture-based or a dialogue-based will be a sensible choice for them. On the other hand, certain gesture could be misunderstood by the computer, particularly if the user has made them without realizing. Or some gesture in some certain culture may be judged to be inappropriate. Culture. Maybe inappropriate. Okay. For O level, I taught some of my students who gets to police the internet. Yeah. Okay, that was very exciting in the class we had. Okay, so let's talk about it. In terms of accuracy, GUI is better than gesture-based for dialogue interface or dialogue interface. A gesture may not point exactly at an icon, whereas a mouse could be more accurately controlled, and the voice input can be misunderstood by the speech recognition software. Okay, so this is very, very important. So we have come to the end of this class. Okay, it's a very, very impactful class, very awesome class. Remember, going back to our lesson objective, so we can just round this up, is the fact that we looked at the characteristics and uses of mainframe computers and supercomputers. We looked at the types and uses of system software. We looked at the need for types and uses of utility softwares. You've come to see the use for it. We look at the use of custom written software and off-the-shelf software, and then the types and uses of user software. Thank you very much. Goodbye. I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE, ICT, O level, AS, and A level. So trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you're giving to them. Thank you very much, and I'll see you in my next video. Bye bye.